Are electric vehicles truly clean and environmentally friendly? Electric vehicles, EVs, have gained significant attention in recent years as a promising solution to combat climate change and reduce environmental pollution. With their zero tailpipe emissions and potential to use renewable energy, EVs are often perceived as a cleaner and greener alternative to traditional internal combustion engine, ICE vehicles. Governments and environmental advocates around the world have embraced EVs as a key strategy to achieve carbon neutrality and cleaner urban environments. However, the question remains, are EVs truly clean and environmentally friendly throughout their entire life cycle? While they offer undeniable benefits, such as reduced air pollution and noise, their environmental impact extends beyond just driving. Factors such as battery production, electricity sourcing, and end-of-life recycling play a crucial role in determining their overall sustainability. This video will delve into the advantages and challenges of EVs, compare them to ICE vehicles, and explore solutions to maximize their positive environmental impact. By understanding the complete picture, we can better assess whether EVs truly live up to their reputation as eco-friendly vehicles. One of the most notable environmental benefits of electric vehicles, EVs, is their zero tailpipe emissions. Unlike internal combustion engine, ICE vehicles, EVs do not release harmful gases such as carbon dioxide, CO2, nitrogen oxides, NOx, or particulate matter during operation. This makes them particularly advantageous in urban areas where air quality is a pressing concern. By reducing air pollution, EVs contribute to healthier living conditions and help mitigate respiratory illnesses caused by poor air quality. In addition to their clean operation, EVs are remarkably energy efficient compared to traditional vehicles. Electric motors can convert over 90% of the electrical energy into motion, whereas ICE engines typically achieve only about 30% efficiency due to energy loss in the form of heat. This higher efficiency means that EVs use energy more effectively, reducing overall consumption and greenhouse gas emissions, especially when charged using renewable electricity. Another significant advantage of EVs is their compatibility with renewable energy sources. EVs can be charged using electricity generated from solar, wind, or hydropower, which further reduces their environmental footprint. As the global energy grid transitions to cleaner and more sustainable sources, EVs become an even more attractive option for reducing carbon emissions. This compatibility aligns with long-term goals of achieving a carbon-neutral future and minimizing dependence on fossil fuels. Lastly, EVs contribute to reducing noise pollution, a less discussed but important environmental issue. Electric motors operate much more quietly than internal combustion engines, leading to a noticeable reduction in noise levels, particularly in densely populated urban areas. This benefit improves overall quality of life by creating quieter, more peaceful communities. EVs offer several environmental advantages, from eliminating tailpipe emissions to improving energy efficiency and reducing noise pollution. These benefits position them as a key player in the global effort to address climate change and build a more sustainable future. Despite their many advantages, electric vehicles, EVs, are not without environmental challenges, particularly when considering their full life cycle. One major concern is the environmental impact of producing EV batteries. Lithium-ion batteries, which power most EVs, require significant amounts of resources, such as lithium, cobalt, and nickel. The extraction and processing of these materials often result in habitat destruction, water pollution, and carbon emissions. Moreover, mining practices in some regions have been criticized for their adverse social and environmental consequences, raising questions about the sustainability of battery production. Another challenge is the source of electricity used to charge EVs. While EVs themselves do not emit greenhouse gases during operation, the environmental benefits are significantly reduced if the electricity they use comes from fossil fuels such as coal or natural gas. In regions where renewable energy accounts for only a small portion of the electricity grid, EVs may still contribute indirectly to carbon emissions. This underscores the importance of aligning EV adoption with a broader transition to cleaner energy sources. The disposal and recycling of EV batteries also present environmental challenges. Lithium-ion batteries have a finite lifespan, and improper disposal can lead to soil and water contamination due to the toxic chemicals they contain. Currently, battery recycling infrastructure and technologies are not fully developed in many parts of the world, leading to concerns about the long-term environmental impact of discarded batteries. Developing effective recycling systems and circular economy practices will be crucial to addressing this issue. Lastly, while EVs are generally more sustainable than internal combustion engine vehicles in the long run, their initial manufacturing process tends to have a higher carbon footprint. This is primarily due to the energy-intensive production of batteries. As a result, the overall environmental benefit of EVs depends on how far and how long they are driven to offset these initial emissions. In summary, while EVs are a cleaner alternative during operation, challenges such as resource-intensive battery production, reliance on fossil-fueled electricity, and battery disposal issues highlight the need for comprehensive strategies to make EVs truly sustainable. Addressing these challenges requires advancements in technology, cleaner energy grids, and improved recycling systems. When comparing electric vehicles, EVs, to internal combustion engine, ICE vehicles, one of the most striking differences is their emissions profile. EVs produce zero tailpipe emissions during operation, which significantly reduces air pollution in urban areas. In contrast, ICE vehicles emit greenhouse gases such as carbon dioxide, CO2, nitrogen oxides, NOx, and particulate matter, which contribute to climate change and respiratory illnesses. However, the environmental impact of EVs is not entirely emission-free, as their life cycle includes emissions from electricity generation and battery manufacturing. Life cycle emissions provide a more comprehensive comparison between EVs and ICE vehicles. Studies have shown that while EV production, particularly the battery manufacturing process, generates higher emissions than the production of ICE vehicles, EVs tend to offset these emissions over time through cleaner operation. The extent of this advantage depends on factors such as the energy mix of the electricity grid and the total distance driven. In regions with a renewable energy-dominated grid, EVs achieve a much larger net reduction in emissions compared to ICE vehicles. Another point of comparison is energy efficiency. EVs are significantly more efficient than ICE vehicles, with electric motors converting over 90% of energy into motion compared to the 30% efficiency of internal combustion engines. This means that EVs use less energy overall to cover the same distance, reducing both operational costs and environmental impact, especially when renewable energy is used for charging. Resource extraction and environmental impact also differ between the two vehicle types. ICE vehicles rely heavily on petroleum extraction and refinement, processes that contribute to habitat destruction, oil spills, and air pollution. On the other hand, EVs require large quantities of lithium, cobalt, and nickel for their batteries, leading to mining-related environmental and ethical concerns. While both vehicle types have resource extraction impacts, EVs hold the potential for improvement through advancements in battery technology and recycling. Lastly, EVs have an advantage in terms of adaptability to future energy systems. As renewable energy becomes more prevalent, the environmental footprint of EVs will continue to shrink. ICE vehicles, however, remain dependent on fossil fuels, which are finite and environmentally damaging. This makes EVs a more sustainable choice in the long term, particularly as global efforts focus on decarbonizing energy systems. While EVs and ICE vehicles both have environmental impacts, EVs offer significant advantages in terms of emissions reduction, energy efficiency, and future sustainability. However, realizing the full potential of EVs requires addressing challenges such as battery production, recycling, and electricity generation. To maximize the environmental benefits of electric vehicles, EVs, a shift toward renewable energy sources for electricity generation is essential. Charging EVs with electricity from solar, wind, or hydroelectric power significantly reduces their carbon footprint. Governments and industries can facilitate this transition by investing in renewable energy infrastructure and incentivizing clean energy adoption. This ensures that as the number of EVs grows, the emissions associated with charging them continue to decline. Advancements in battery technology also play a crucial role in enhancing the sustainability of EVs. Current lithium-ion batteries rely on resource-intensive materials such as cobalt and nickel, but ongoing research aims to develop alternatives using more abundant and environmentally friendly resources. Solid-state batteries, for example, promise higher energy density, longer lifespan, and lower environmental impact. Accelerating the development and deployment of these technologies will address many of the challenges associated with battery production. Establishing efficient battery recycling systems is another critical step toward reducing the environmental impact of EVs. Recycling not only minimizes the disposal of toxic materials, but also recovers valuable components like lithium and cobalt, reducing the need for new resource extraction. Governments and manufacturers can collaborate to create closed-loop recycling systems, ensuring that old batteries are reused or repurposed rather than discarded. Promoting sustainable manufacturing practices is equally important. Automakers can reduce the carbon footprint of EV production by adopting cleaner manufacturing technologies, using recycled materials, and improving energy efficiency in factories. Additionally, transparent and ethical sourcing of raw materials can address social and environmental concerns linked to mining operations. Encouraging shared mobility and public transportation can also reduce the environmental burden associated with EV production. Car-sharing programs, electric buses, and other forms of shared electric transportation decrease the total number of vehicles on the road, optimizing resource use and reducing emissions. Urban planning strategies that prioritize public transit and non-motorized transportation can further complement EV adoption. Finally, consumer education and awareness are vital. Encouraging responsible EV use, such as charging during off-peak hours to reduce grid strain and maintaining vehicles to prolong their lifespan, can amplify the environmental benefits. Governments and organizations can play a role in providing information on best practices for EV ownership and advocating for policies that align with sustainable goals. While EVs have inherent environmental advantages, their full potential can only be realized through a combination of renewable energy adoption, advancements in battery technology, efficient recycling systems, sustainable manufacturing, shared mobility initiatives, and consumer education. By addressing these areas, EVs can become an even more effective tool in combating climate change and promoting environmental sustainability. Electric vehicles, EVs, represent a pivotal step toward a more sustainable future, offering substantial environmental benefits such as zero tailpipe emissions, improved energy efficiency, and reduced noise pollution. However, their true environmental friendliness extends beyond their operation and depends on addressing challenges associated with battery production, electricity sourcing, and end-of-life management. While EVs already outperform internal combustion engine, ICE vehicles in terms of reducing greenhouse gas emissions and air pollution, maximizing their environmental potential requires a holistic approach. Transitioning to renewable energy for EV charging, advancing battery technology, implementing effective recycling systems, and promoting sustainable manufacturing practices are critical steps in this journey. Additionally, integrating EVs into broader sustainable transportation strategies, such as shared mobility and public transit, can amplify their positive impact. In conclusion, EVs are a powerful tool in combating climate change and fostering a cleaner environment. However, their success relies on continued innovation, supportive policies, and collective efforts from governments, industries, and consumers. With these measures in place, EVs can fulfill their promise of being a truly clean and environmentally friendly alternative for future generations.